Hey, how's it going? In this video, I'm gonna be taking a look at some of the new exciting projects out there. When it comes to data storage, there is a project called Silica. Let's delve a little bit deeper and try to understand this project and what this project is all about when it comes to data storage. Project Silica is a research project that aims to develop new type of data storage using quartz glass. So that would be a main difference compared to some of the traditional ways of storing information, where it perhaps would be drives. Within this particular way, all information might be stored in glass, I guess. The project is part of bigger, broader initiative to explore innovative and long-term storage solutions that can be addressed or challenge the way how we currently storing data, in particular taking a look at durability and longevity. If anything, perhaps those two uh, problems would be addressed within this project. Let's delve a little bit deeper and take a look at the main components and parts of this project, right? Quartz glass storage, unlike traditional data storage methods like hard drives, most likely most information currently is being stored in the hard drives, and we're talking about a lot of data and the way how this data is currently being processed and stored, as well as our optimal disks. So that would be currently the way how most of the data would be stored, right? And we progressing into this particular project, Project Silica, and utilizing quartz glass as a storage medium. So we're taking a look at the glass and how we can potentially store information in glass. Quartz glass has the potential to store data in more durable and stable manner compared to conventional storage technologies. This is how this project has been promoted. Again, I'm not supported by any of those projects, but if anything, I'm interested, right? And taking a look, and it's something that I'm always interested in new trends and new opportunities and new exciting projects of that. Data encoded in glass. The process involves using laser to encode data in the form of 3D gratings or layers within the glass. Each piece of glass can potentially store large amounts of data in a compact space. Okay, that sounds very challenging and hard thing to do. I don't know. I mean, if you can do it, it's great. It sounds very challenging. Part three that we're gonna be taking a look at, that will be durability and longevity. Quartz glass is known for its durability and resistance to environmental factors, making it prominent material for long-term data storage. Perhaps this particular area that they're looking to address, in particular when it comes to storing some of that information up there, and they're looking for that information to be there for perhaps hundreds, if not uh, thousands of years. Or I don't know how ambitious the project might be. The goal is to create a storage solution that can prevent data from 400 or even 1000. Yeah, exactly. Exactly, that's the thought. Because the process might be not the optimal when it comes to price of building some of those systems, but perhaps that's particular area that they're looking to solve. Number four, applications. Project Silica is envisioned as a solution for long-term archival storage, especially for important data that needs to be preserved for extended periods, such as cultural archives as well as scientific data or critical historical records. I understand it, great, right? But as well as perhaps having systems, how you that data would be read later. Even now, we would be going to some of those places, and there would be a lot of writings on the wall, and cells will not really understand the process, how to read those writings, if that makes sense. So whereas next or future generations might find a lot of glass and will melt that glass and build something out of that glass without having systems to actually process that glass. Number five would be challenges. While the concept holds promises, these are challenges in terms of scalability, cost effectiveness, and the development of practical systems for reading and writing data into glass. Yeah, again, yeah, I can understand, but that would be similar challenges with the most of the projects, right? And we're taking a look at scalability, cost, and perhaps necessary equipment that will require working with glass. Yourself, if you're interested in learning more, I have published a book, Project Fit Flow. Within this book, I'm sharing a lot of information and everything what you would need to know about your body, and particularly when it comes to placing a lot of stress on your body. Hopefully, by doing that, your body can adapt to that. And to do it successfully over long periods of time, you need to understand some core principles and something that everyone would need to know. Some of those areas can be rest periods and nutrition, and then placing a lot of stress, right? How to do that effectively, safely, so you can potentially not injure yourself. That would make impact or discourage you from carry on with the process. When it comes to working out and doing your best in the gym, I would leave a QR code in the corner, as well as there's a company's website below. If it's something that you're interested, you can find it there. Let's have perhaps a little bit of fun and take a look at this project and discuss potential pros and perhaps why would anyone would consider instead of carry on with the way how things are being done right now, perhaps, and take on and trying new ways of storing information within this project and some of those storage solutions, right? Some of those areas can include durability and longevity. Quartz glass is known for its stability and resistance to environmental factors. This could result as storage medium that's more durable and has longer lifespan compared to traditional storage solutions. Number two, data preservation. The project aims to address challenges of long-term data preservation. If successful, project Silica could be used for archiving important culture, scientific and or historical data, as well as whatever people might think is important, perhaps leaving a trace, right, after themselves. Some important, perhaps, discoveries, a lot of information, right? As well as number three would be compact storage, so addressing that. Quartz glass has the potential to store large amounts of data in a relatively small space, which could be beneficial for organizations with the vast data storage needs. So again, so how much data we as a society might be interested in storing, right? There might be a lot. In particular, we're gonna place it in the rock somewhere, so it would not necessarily get lost. I don't know. As well as number four would be security. The physical properties of quartz glass could make it resistant to some forms of physical damage, adding an extra layer of security to store data. So perhaps those four areas would be pros. Why would everyone might be interested in doing something like that? And let's take a look at perhaps challenges or cons. Why that not be the most optimal thing to do. Starting with the first part, that would be cost. Developing and implementing a new storage technology can be expensive, and perhaps when it comes to adapting to your new solutions, right? The cost effectiveness of Project Silica compared to existing storage solutions is a crucial factor in its feasibility, or how potentially new technology can overtake and how much better new way of storing information should be compared to existing ways or systems. Next one, and for those of you prototyping and from there once you have working prototype, as a business owner that perhaps works on products or services, you yourself, you need to take into account how you're gonna scale that effectively. While the concept may work, which is which is great always, on a smaller scale, in the research setting, scaling up the technology for practical large-scale use presents challenges. Ensuring effective read and or write processes on a massive scale is non-trivial. Then it comes to perhaps as well as, can you scratch it? If we're talking about glass, right? So in laboratory it might work, but not necessarily when you're working with tens of thousands, millions of people, right? If you would just scratch it, it not necessarily would be able to read data from the glass as time goes. So there's a lot of things there. Read and or write speed. Okay, so that's a challenge. I thought that they could potentially use that to improve existing way how data can be processed. The speed of which data can be written or to and read from quartz glass may not be the fast as some existing storage technologies. This could limit its use for applications that require rapid data access. Okay, so that perhaps would be a big issue, but perhaps they can improve that when it comes to systems and building those systems. Perhaps there's solutions there. I thought it might be more better, but perhaps currently with the existing way of how data can be processed, sticking to what we're doing now might be the optimal way. Number four, technological obsolescence. The technology landscape evolves, and what is cutting edge today may become obsolete in the future. Ensuring that the project Silica remains relevant and adapted to future technologies advancements is essential. I mean, not necessarily essential. It depends, right? So they have proposed this project. I wouldn't say it's essential, but unless they can propose even better ways. So unless someone can propose better ways, and then we can sit down and take a look at all the proposals and see which one might be the best, or perhaps go ahead and launch 5 or 10 of those projects and see which one of those projects might succeed in the long run. Interoperability, compatibility with the existing systems and or standards is crucial for the success of any storage technology. Ensuring that data storage in quartz glass can be easily accessed and integrated with other technologies is significant challenges. Ooh. So they perhaps we can come on. There's a lot of finances there. They just need to find smart people who can build those systems around some of those existing solutions. And the last one would be energy consumption. The energy requirement for manufacturing and or reading writing data to quartz glass should be considered, especially in comparison to other storage technologies that are energy efficient. So we coming back to, which is kind of important, but I don't know if that many people taking that into account. It's good that they did, but either way. I don't know. It seems interesting. I find that some of those projects very interesting. Thanks for watching. I'll see you next one.